What if your car could recharge itself every time you slow down? That's exactly what electric vehicles do, using something called regenerative braking. But how does slowing down a car magically turn into electricity? And why is it so important that EVs can't function efficiently without it? Let us break down the hidden science that makes regenerative braking one of the smartest inventions in modern transportation. In a regular petrol or diesel car, when you hit the brakes, all the car's kinetic energy, the energy of motion, is wasted as heat. Brake pads press against a spinning metal disc, creating friction. The friction stops the car, but all that valuable energy disappears into the air. Imagine throwing away fuel every time you slow down. That's what traditional braking does. Electric vehicles use motors that can run in two directions. As a motor, using electricity to spin the wheels; as a generator, using the wheels to create electricity. When you press the brake pedal in an EV, the motor switches roles. Now, instead of consuming energy, it produces energy. The spinning wheels turn the motor's rotor, and this motion creates an electric current. The EV captures that electricity and stores it back in the battery. It's like charging your phone simply by sliding it across the table. EVs are designed around energy efficiency. Their batteries are powerful but heavy, and every kilometer of range is precious. Regenerative braking helps EVs by 1. Extending driving range. Depending on speed and driving style, regenerative braking can recover 10 to 30% of the energy you use. That could be enough to drive several extra kilometers every day. 2. Reducing wear on brake pads, less friction, less maintenance. Some EV owners drive years without changing brake pads. 3. Improving efficiency in city. Driving stop-and-go traffic becomes an advantage instead of a waste. Every slowdown becomes an opportunity to recharge. 4. Managing battery health. The system prevents unnecessary heat buildup by taking load off the mechanical brakes. When your car is moving, it has kinetic energy. Regenerative braking converts that kinetic energy into electrical energy. Physics says energy cannot be created or destroyed, only transformed. Instead of turning motion into heat, like gas cars, EVs turn motion into electricity. The electric motor acts like a dynamo. Spinning a motor forces electrons to move inside its coils, generating electricity. This process also creates resistance inside the motor, which naturally slows the car down. That's the braking effect. You're basically using physics to your advantage instead of fighting it. If you've ever driven an EV, you know the braking feels smoother, or even stronger in one-pedal mode. Here's why. The motor can slow the car instantly by increasing electrical resistance. The system is controlled electronically, not mechanically. Engineers tune the response to feel natural and safe. Some EVs even combine regenerative braking, traditional brakes for maximum stopping power. Regenerative braking makes EVs more energy efficient, cheaper to maintain, longer lasting per charge, better for city traffic, more environmentally friendly. It's one of the reasons EVs outperform gasoline cars in daily driving efficiency. So the next time an EV slows down quietly, remember, it's not just braking, it's recycling energy, extending range, and making transportation smarter. Regenerative braking isn't just a feature. It has a fundamental reason: EVs are the future.